everybody, welcome to another Haas Talks Foss. I am here with our famous two engineers from Uber. I've got Himank and Ovais. Ovais and Himank, welcome to the Haas Talks Foss. I appreciate you guys stopping by. How are you guys doing today?
Doing good. Thank you, Matt, for having us here. It's great to chat with you. Normally, we would meet up in Percona Live in person, but pandemic didn't really allow us to do that. So I'm looking forward to talking to you in person as well. But other than that, it's great to be here. Great talking with you.
Well, the good news is online conferences are still here, but in person are starting to show up. I know, like this year, for instance, the OS Summit and AWS reInvent, those are all going to be in person. So there are going to be opportunities, especially getting towards the second half of the year and next year, for all of us to potentially meet up at various conferences. So that's going to be really exciting. And I don't know about you, but I'm really looking forward to getting out of the house. I think I smell from all the time here in the house. Like you got to blow that off. So not a great thing. But yes, really looking forward to seeing you again in person, Ovais. For those who are listening and don't know, Ovais used to work at Percona, and so I've known Ovais for years and years now, and it's great to see him do all the awesome things that he's doing. Ovais, why don't you tell us a little bit about your background, just for those who are listening who might not know who you are?
Sure. Yeah. So I have been in the database industry for more than 15 years, and including the Percona time that you mentioned. Apart from that, I did some time at a startup called Lithium, also doing the database infrastructure over there. And then for the last 5 years, I've been at Uber, again in the database world. And here at Uber, I lead the storage org. My team is responsible for providing a fully managed database, blob storage and cache solutions, and you can think of it as as private cloud PaaS offering if you were to compare it to AWS or Google, but for internal users. So the internal users or the internal services get the same kind of feel that they would get if they were using in Amazon. They don't have to worry about the operational procedures or their operational needs. Everything is fully managed for them. So that's kind of what would summarize what I'm doing at Uber.
Okay, and just to clarify, when you talk about users, you're not talking about Uber users, you're talking about developers within Uber, and those who are developing applications or using the data for analysis or whatever.
Yeah, thank you for clarifying that. Yes, when I talk about users, and this is a term that we use internally as well, when I talk about users, I'm mainly referring to the developers at Uber who are developing all of the services that make up the Uber ecosystem.
Now, what's funny is for us database folks, it's interesting because we've seen this evolution around users and who our users are. We used to, build, things specifically for application groups or, things like that. But now we're building apps that serve people building apps, as opposed to just, like having that one-to-one connection anymore. It's about, building and scale. So
yeah,
I think interesting.
Yes, I think that cloud. I think we should really thank the cloud for that kind of transition. I think that we have moved away from, in the past where we used to think more as a DBA. When you think of a database, you think of a DBA, right? But we have kind of moved away from that, and that is due to the explosion of services, especially moving towards a microservice environment. It's not really possible to be a DBA for all of these services, right? And that's where you start thinking about, okay, how can I provide a managed database solution, which is not just a database infrastructure, but which also can do most of the things that a DBA would do automatically, right? So prevent anti-patterns, provide an abstraction layer, restrict bad usage, right? And be smart enough to, where I'm going with is be smart enough to suggest how to write more performant, for example, queries, right? And to be able to suggest what kind of schema you should have, what kind of indexes you can have. I think that is the way to really scale a DBA role in this microservices world.
Yeah. And so being in charge of that PaaS solution, obviously, and that infrastructure, you need people who can understand and have that vision to implement a lot of what you're trying to build. And that's why we have Himank on the phone here as well with us. Hi, Himank. Who is, architecting DocStore and some of the other back-end features that, you talked about at Percona Live. Himank, why don't you give us a little bit of background about you and tell us about, your role?
Yeah. First of all, thanks, Matt, for inviting us for this talk and looking forward for this. About me, my main focus area since I did my school was in distributed systems and mainly targeting distributed databases. Prior to Uber, I was working with Yahoo Mail. There also, I was looking into their backend system where I was working with the similar databases like HBase. And when I joined Uber, since last 5 years, I've been part of the storage. And in the storage, I'm working on all different storage systems, what Uber offered to our internal users. And lately, I'm involved with this DocStore project, where I'm tech leading this DocStore project and working along with Ovais on that. And, and the journey so far is mainly in the distributed databases.
Okay. Yeah. And I think that right now we're seeing this wave of database evolution into this distributed database mindset because of, as you mentioned, like these microservices and how developers are designing applications. They have to be resilient, they have to be portable, they have to, conform to some sort of standard. A lot of people are looking at deploying via Kubernetes or via, containers. And that changes the thought process around how you interact with the databases themselves. It's no longer a single database that is a monolithic system that everyone connects up to. Now, it's a new challenge. And so that leads us to, your guys' infrastructure. So you've got a really big, complicated, data footprint, don't you, Ovais?
Yeah, we definitely have a huge footprint if you look at Uber's business and the amount of rides you're doing, the amount of orders that are going through and getting processed through the system. If you look at Uber Eats, for example. So yeah, we have to deal with the massive amount of data. We have to deal with the massive amount of QPS, and that automatically means that we have a massive infrastructure footprint as well. And that again is the reason I was mentioning that we have moved away from the individual DB mindset, because at this scale it's not really possible for us for to have human operators that are humanly managing all of the systems. We need to have systems in place that are self-managed, right? And that's where we are going with what we're developing Uber. That's exactly why we started DocStore as well. And to your point about all of these microservices and how there's a shift from moving from monolithic to microservice architecture, that's one part of the boom for distributed databases. The other part is the amount of data that gets processed these days, right? No one thinks about how much data they want to store because the storage is kind of cheap, right? So yes. That's another reason why we invested in DocStore, is we wanted to build a system that can scale with the application, that can work on small data set, medium data set to very large data set, and prevent having the user to have to migrate from one offering to another, right? Which is and just let them focus on whatever their business logic is.
Well, what's funny is the concept of storage is cheap. It only extends so far, because when it's 10 times cheaper but you store 10 times more data, it costs the same. Right? I mean, because you've just got more, and it introduces a litany of other problems, because you actually have to process that data, and a lot of times the performance implications of having 10 petabytes versus 1 petabyte or 1 terabyte of data, it's vastly different. And that's something that a lot of people don't consider. They just think we're just going to store it forever. We're going to keep it into whatever storage mechanism, whatever data lake that we have out there. We're just going to keep it out there, and eventually we'll use it. But there's all kinds of cascading implications. Now, you mentioned DocStore, and that's really what I wanted to talk to you about, because both of you presented at Percona Live on this, and this was an exciting topic. I like to learn about why people are building new databases, new features. So maybe just give us a quick overview for those listening who haven't seen the presentation. What is DocStore?
Okay, sure. First I will go ahead and talk a little bit about it, and then I would like Himank to talk a little from the technical perspective as well. So DocStore has been designed as a multi-model database. It provides best of both the worlds. When I say both the worlds, you think about relational world and the document world, right? It provides the same level of flexibility that you would get from a document model, and at the same time structured approach that you will see in a relational model. When we thought about building DocStore, we did not want to enforce any restrictions in terms of what kind of data model the applications are going to use, because we really wanted to build a database that can serve almost all of the operational database use cases at Uber, right? So we wanted to support a wide variety of data models, whether it's relational model, it's a hierarchical model, or it's a document model similar to MongoDB. So DocStore, that's what I would say from a usability perspective. From a technical perspective, it's a distributed database that's built on top of MySQL. We use MySQL as a storage engine, and on top of that, we have a data distribution layer that's responsible for sharding the data set, then query processing layer, and a caching layer. And all of these TLs come together to form the DocStore product. And I'll let him talk about the technical side of it.
Yeah, and Matt, when we started this DocStore, few things we kept in mind is like what type of functionality that we need to support. And there we talked to multiple users, and there we figured out that, okay, this database itself has to accommodate few functionalities like transactions, and then consistency, which is very important for our developers as well. And there we implemented Raft protocol to ensure transactions are durable across the quorum number of nodes. And then we have different layers, as Ovais mentioned, like how to route these requests, how to provide these client drivers to our users, because in Uber we have Go and Java, so we need to ensure that we have methods for both, and then how routing needs to happen, and then how to have secondary indexes, replication, and all typical functionalities that we need to implement in the database.
Okay, and so as you were building this, you had to implement a lot of these different details, and you mentioned that MySQL is the underlying layer. So does that mean that there's a proxy or a routing layer that actually handles most of the interactions with the developers and has sort of an API, and then from there you call down to MySQL?
Yeah, that's correct. So what we have done is we have implemented different layers. And the topmost layer that we have is our client that talks to our gateways. So we have our own gateways. And what we have done is we have provided a structured APIs to our client. And all they need is just to call these structured APIs. So for example, if they need to just insert, they simply call insert. That's it. And then our client drivers automatically figures out that how it needs to route to our gateways. Then gateway understand that, okay, where is the other layer, lower layer, which is responsible for running Raft protocol is running. They route to those, and they figure out, okay, this is the shard, and that layer talks directly to MySQL. So everything is hidden with all these layers, and users simply talk to our client.
Now, is the API like a REST API then that is just very basic, or does it accept SQL directly?
So right now, these are REST APIs, but we have what we have also done is the query APIs that we have is similar to what MySQL supports, the MySQL syntax, but it is still structured APIs that we support.
Okay. Now, so Ovais, as you were building this out, and as this vision formed, why not look at some of the databases that are already out there? I mean, it seems like every week there's a new distributed database that pops up, over, the course of the last several years. I mean, there's dozens. And I mean, certainly there are some that have become very popular. Why build your own versus some of the things that are already out there?
Yeah, that's a great question. So we actually have experience building database since 2015. So we had an early incarnation of a distributed database, again on top of MySQL, that was called Schemaless, and there are a few blogs as well on the Uber Engineering blog about it. And then Cassandra also got introduced into the mix, right? So Schemaless was a append-only database and had more data modeling restrictions. So from a usability perspective, it was a bit hard to use. It was scalable, but not as usable, and that's how Cassandra came into the picture. But having developed an initial incarnation of a distributed database and having operated one of the largest Cassandra deployments, what we realized really from, for example, from Cassandra perspective, that users do care about strong consistency. which is not something that Cassandra was providing. And without having a strong consistency, we saw a lot of complexities in terms of the application architecture. So let's say there's no notion of transaction. I mean, the lightweight transaction exists, but it's not scalable. So typically applications end up plugging in other systems. So for example, they would use Zookeeper as a distributed lock manager, and then use that to coordinate the writes to Cassandra. So and this is something that was happening on many different applications that were using Cassandra. And if you look at the Uber workload, it is because of the physical nature of it, because someone is wanting to get a ride, right, and you don't want multiple people to get the same ride. Look what kind of user experience we would have there, right? So the kind of consistency that is needed is really important, and that's where we found so many problems from increased complexity on the application side that we said that we need to have a system that can provide us the same level, that can provide us with a strong consistency. So that was go ahead.
So is that a function, and I've seen this in a lot of other companies and a lot of other infrastructures where, you start off with a technology that fits a specific need, and then you start to evolve it to match other needs. And you might like it because it has certain features, and then you start to bolt on technology on top of technology. And you try and overcome the limitations as opposed to using the right tool for that particular use case, which might be completely different. So with Cassandra, you mentioned the consistency. It might be that there needs to be more reporting. There might need to be more, things that it just doesn't work. So you're bolting on solution on top of solution until you have a Frankenstein monster. And at some point, you just need to kind of walk back and say, like, okay, we chose the wrong tool initially based on what our needs are now. Is that what you're saying?
Yeah, that's exactly what I'm saying. Consistency is just one part of it. Like if you have an operational database that is responsible for processing and storing all of the transactions related to business operations, you need that data. For example, one of the important use cases make that data available for business report, right? So let that data flow into the data warehouse and make it available for business reporting. And that's another area where there isn't a good story with Cassandra. There's no concept of having a consistent log that can be used to move this data from Cassandra to the data lake. Yes, there's a CDC feature that was introduced a little time back, but it's not really production grade. So there was these type of challenges that where Cassandra really fits in well is that you write a data, you don't really care about whether data is made available or not, whether it's consistent or not, and then you can read, and then you get to read something that may not be consistent, right? So this is not something that we need from a business perspective, and those are the limitations that made us move away from Cassandra.
So you're really, from a DocStore perspective, you want flexibility, consistency, and ease of use, right? That's what you're looking for out of this for your developers, to give them a universal interface to be able to handle a wide variety of different workloads. So you're looking for the one ring, the one ring to rule them all, right? To have all of the data kind of like flow through and have some conformity.
Yeah, one ring for operational data set. So it might seem like it's not possible, but if you look at how our applications typically use a database, what do they need, right? They need to be able to store large amounts of data. They need like efficient processing and be able to query the data set as and when they need. This and they need high availability, reliability, consistency, performance, right? So it is definitely, I mean, what we have found is definitely possible to build a database that can offer all of that, and that's where DocStore comes into the picture. Now, to your other question about why did we end up building something ourselves, as I mentioned earlier in our discussion, that we did have a previous incarnation schemaless, which did have some of the building blocks that we could use to build out a new database, DocStore. Yes, there were issues with it from a usability perspective. And for example, it didn't have CRUD, it didn't have a notion of transactions, but it still has some of the building blocks that we had built for it that could be used to build out a new database. And then we had an operational expertise around like managing a MySQL based system, running and managing some of the components that I mentioned that existed in schemaless. And if you bring a completely new system into the mix, which hasn't been proven at the scale that we are at, then I would say that we are at mercy of the system. I think that that would be a very risky decision to make. And if you think about life of a product, where do you end up spending most of the time? You end up spending most of the time running it in production, right? 80, I say
That's
that
true.
the 20-80% applies to it as well. You spend 20% time developing it, you spend 80% time running it in production, maintaining it, understanding it, debugging performance issues, fixing them, right? And if you have an expertise around a system, if you have built out something that or components that you can reuse, then I would say that that's the way to go, because the 80% time would be best applied there.
So building a database, though, or even a distributed system like this, is not for the faint of heart. I mean, let's be honest. Most companies probably won't be able to pull it off because they don't have the engineering, background and maybe the details that you guys have at Uber. They might not even have the workload, and it's an expensive endeavor in terms of time, resources, and knowledge. And it's potentially fraught with challenges that you have to overcome. So Himank, as you've built this out, as you've been designing this, what are some of the challenges that you had to overcome, that you found that this was a really difficult thing, and we had to overcome this, and we're happy that we did, but it was tough.
Yeah, I think one of the challenges that we had was supporting transactions. It sounds simple, but when it comes to production, when you have to scale it, there we see a lot of challenges, and there we end up spending a lot of time. But I think it was one of the best decisions, because now we are serving it on the database layer, and application don't care about it. But earlier what was happening is every application developer has to implement it in their application side. So transactions, definitely one of the features that we thought that earlier we thought it was easy to implement, but scaling it was challenging because there were a lot of corner cases that we have to deal with. And the other part of that would be to teach our developers like how to use it in the production and how not to misuse it. Because when you expose these functionality, chances are that people may misuse it. And similarly, we are, and I think we will convey it towards the end of the talk, but we are also implementing 2PC. And there are a lot of challenges that we have to figure out, a lot of corner cases that we have to figure out. And these are some of the challenges that we faced while we were developing DocStore.
So from a transaction perspective, when we talk about that challenge, you're talking about you've got this distributed system, you've got shards, and you might have a transaction that crosses a dozen different shards. How do you ensure the consistency across those dozen shards?
Yeah.
Is that kind of okay?
Yeah,
and that is a challenge.
Yeah, and then on top of that, we have wrapped, so we also need to understand the nuisance of it, that okay, what will happen if you have two nodes going down, or what will happen in the corner cases when the leader is not up, and these type of things. Again, it won't come during the development, but when we were scaling it, when we had traffic on the instances, then we had to figure out all those things in the production.
Okay, and I mean that's a big challenge. I know that in a distributed system, that's a key area for a lot of different people. Now, you mentioned something that's interesting that most people don't think about, which is the developer education. Whether you're choosing a new database that you've built or a new technology that you're implementing, it's those pesky developers who often cause a lot of those issues, and It's interesting because I've seen this where people don't understand the technology necessarily, so it's very easy for them to misuse it, right? So I like the Spider-Man phrase, with great power comes great responsibility, and so you've developed this system that has this immense amount of power. How are you going about training them and making sure that they do things that aren't going to hurt the system? I mean, are there checks and balances in place?
By not giving them the power.
Okay, explain. I mean,
yeah. So while DocStore is featureful, we have restrictions in place which prevents the developers from using bad design patterns, right? So think of it this way: what are the different type of bad design patterns can we see? Maybe someone choosing a not that selective field as a key, right? So for example, someone choosing gender or a city name as a key, right? There are not that many distinct values, and what that means is that the data is going to be not well sharded, right? Then the other examples of, for example, people using transactions the wrong way. For example, keeping the transaction open for too long, doing some other remote operations, and then committing and causing a huge amount of log contention, right? So we have restrictions in place, or storing very large blobs into the database, which is another anti-pattern. So we have restrictions in place that can prevent these type of anti-patterns, and that's actually one thing that I wanted to add when I was talking earlier, is that whether you are using whether you're building your own database or you're using something open source that already exists, right? You need to have an abstraction layer in front of it. You cannot simply expose the full feature set of that particular functionality, because generally, if you look at an OSS database, it is developed for a wide variety of use cases. So it has a lot of feature set. Not all features are supposed to be scalable, right? So, and if you just give people the full power, as you mentioned, full power to do anything, then they are going to misuse it. We cannot expect the developers to know the nitty-gritty of each and every feature of the database, right? And that's where you need to have an abstraction layer in place, which not only abstracts away the database, but also restricts the amount of functionality that is available. And the less obscure functionality that is used, the easy it is for other developers who might end up working on the same code base. So that's where I think the way we are handling it is not just by teaching. Yes, teaching for sure is important, but by also restricting the API, thinking about the anti-patterns, and especially taking our experience and building our protections in the system so that these anti-patterns don't get applied, right? Preventing hot shards, things like that. And that's where we feel like DocStore excels as compared to some of the other systems as well, in that it really makes sure that even if developers do not have full knowledge of the nitty-gritty of the system, it's not easy to make it misbehave.
So narrow the feature set to what is really needed, keep it simple and straightforward, and eliminate those edge cases from being exposed to everyone until they're needed.
Yep.
And then you can work on how to implement them best. Okay, that makes sense. Now, I know you both are on this team is responsible for all of the management of data from the operational standpoint at Uber. So you're talking petabytes of data potentially here, right? So just outside of even DocStore, I always like to hear what are you seeing with a challenge of managing an environment that size? Like, it's a massive environment, and what sort of problems do you see crop up more often than you'd like? What are the recommendations for people who have these scalable environments that aren't Uber scale yet, but maybe they will be in a couple of years? What are the things that they should look out for?
Yeah, most of the problems that we see, or most of our time gets spent on operational issues, right? So the first thing that I would really recommend is to focus on platform automation. Make sure that everything is fully automated, because as you scale, it's like as I mentioned earlier in the discussion, it's not really possible to throw human at the problem, right? So think of things like how do I scale out? How do I add new nodes? How does leader election happen? How do I provision these databases? How do users interact? And as much self-service as the developers can do themselves, the better it is for the system, so that the team can focus more on maintaining and developing the system and taking it forward, right? So the automation part is really the key. The other part to think about is don't make the database a dumpster, right? So make sure that developers understand what kind of data they are storing, and that's where one of the key features of DocStore is schema enforcement. So as soon as you enforce a schema or force the developers to think about the schemas, they start thinking about the relevance of the data and what they are going to be storing in it, right? And that is kind of one way to make sure that database just doesn't get up being a dump of all kinds of different types of data.
And database design matters, and I think this is where it's interesting as we look at all these automation tools, whether it's in the cloud, whether it's systems you're building yourself, whether it's trying to run via Kubernetes, whatever. The automation and the operations take you so far, but from a database design perspective, a crappy application, a crappy design system is still going to perform poorly no matter how much awesome infrastructure you put behind it. And I think that's a key lesson that a lot of people don't take to heart, and I think that causes more issues than the infrastructure does in a lot of cases.
Yeah, for sure. And the other thing I would say is it's necessary to have the right abstractions in place. Make sure that you do not, even if you're using an OSS system, make sure that you do not expose the internal APIs of the system, because in some part of your journey, like we are in a journey of migration as well, you would realize that what you have doesn't really work, doesn't really scale with you. And especially in a microservices world where there's no monolithic application, for there are thousands of applications out there, it's really challenging to move people from one technology to another. So thinking about a right abstraction in place actually makes it easy in the future to evolve the system, right, and like seamlessly migrate to another technology, another storage engine. That part also is really important. And the final piece I would add is around efficiency. I think that is the biggest challenge, that as you scale, as you grow bigger and bigger, you can't just throw hardware at the problem. You need to think about efficiency. You need to think about how data is getting stored. And especially today in our world, there's a lot of requirement around, there are a lot of regulations which make it that you need to make sure that the data is properly protected. You need to have a history of, for example, all the changes that got made, let's say on a user account, or you need to store a large amount of data. And that's where from the get-go, think about tiering, think about how you can bisect your data into what is hot, what is frequently used versus something that needs to be kept around for regulatory reasons, or that's not accessed that frequently. Thinking about these things right from the get-go would make it easy as like companies transition from like a small scale company to, let's say, Uber scale company.
Great. Well, Himank and Ovais, thank you for showing up and talking to me a little bit about this. I know that you have a Percona live session floating around there. I believe it's out on YouTube if you're interested in checking out more details on DocStore. It should be available out there for free. If you'd like, I know, Ovais, you're always hiring. So if you're interested in working on Uber scale problems, Ovais is always hiring DBAs and engineers to help him on the storage team, and would probably welcome some awesome engineers to the team.
Yeah, thank you so much, Matt, for mentioning that and bringing that up. We definitely are always looking for engineers with database experience, both from a management perspective as well as development perspective. And Uber is a great place to work. Working with Himank, whoever comes and works with Himank will learn a lot on the distributed database side as well. So I would say this is a huge opportunity. As you mentioned earlier, not every company gets to build a database. So I would say come join this journey and help us take DocStore forward.
All right, great. Thank you both. I appreciate the time that you spent today, and we look forward to seeing how DocStore grows and evolves over the next few years.
Thank you, Matt, for inviting us.
Thank you so much, Matt, for having me here, and it was great chatting with you. I look forward to seeing you in person as well in one of the conferences soon.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.